The first speaker is going to be Dr. Phyllis Zee. And Dr. Zee is going to give us a very broad overview of sleep and its association with other biologic and metabolic systems in humans. And I'll introduce Dr. Zee. For most of you, you know Dr. Zee. She's one of the giants of the field. I will say now, I signed off yesterday that I'm your supervisor. I'm listed. She is working at the NIMH on an interagency agreement. So she's going to be working with us and consulting with us on some studies that we're actually trying to bring sleep to the National Institute of Mental Health intramural program and working with other agencies in that endeavor. So Phyllis is the Benjamin and Virginia T. Bosch's Professor of Neurology, Professor of Neurobiology at Northwestern University, and you're the Director of the Center for Circadian Sleep Health and Chief of Division of Sleep Medicine at Northwestern University's Feinberg School of Medicine. Phyllis?
Great. Thank you, Kathleen, for that introduction. I also like to thank the National Academy and Louis and Francis and John for the invitation. And Kathleen, thank you very much for inviting me to speak here. So in the next 10 minutes, hopefully it's just going to be 10 minutes, that I'm going to try to provide an overview. And some of it is going to be quite biased because it's going to be some of the work that we've done, but I think these are just a few of the examples. Here are some of my disclosures, which I have quite a few, but I don't think any of these directly affect what I will be speaking about today. So this has been shown already by Amita. This really circular plot of all of these physiological, behavioral rhythms that are both diurnal as well as there's a circadian basis for all of these. And I'm not going to go through all of these, but just to mention two other things. One, these physiological behavior rhythms that occur in this near 24-hour or if entrained to the rotation of the Earth on its axis, the natural light dark cycle, they're aligned with each other, and therefore you see this beautiful synchrony. Of course, sleep, as mentioned earlier, is one of the most prominent of these physiological and behavioral rhythms that we see, and we have, for example, timing of non-REM sleep, REM sleep in the earlier morning hours. And as already mentioned, there's something different. It isn't just a rhythm, sleep and wake, but also that within sleep itself, there are prominent changes in reasons like blood pressure, cardiometabolic changes are related to both during sleep, but also regulation of these parameters during wakefulness, mentioned lymphatic flow, and even neuronal firing changes across the day. So when we look at sleep, we can think about, from human standpoint, mostly the EEG. And you can see that there is what we would call a structure or architecture where you go from REM, non-REM to REM sleep, and REM becomes more and more prolonged and prominent in the early morning hours. What's really kind of neat with the EEG is that there are different, types of frequencies. And of the one that is most, that has been studied a lot, has been the frequency of the slow activity or slow oscillations in non-REM sleep, as well as spindle activity, especially as it relates to memory consolidation, as well as cardiovascular and metabolic regulation. And this is to show, for example, a study by Redline and Javahari showing that during that first part of sleep, during the deeper stages of sleep in non-REM sleep, that blood pressure dipping occurs at its highest level. And then also data from our laboratory showing that the amount of slow wave sleep activity across the night is related and it's regulating autonomic function, so favoring the parasympathetic activity in comparison to that of the sympathetic tone. Now, the concept of sleep is that we heard about sleep duration. How many hours of sleep do you need? I think what we're moving towards is a multi-dimensional domain of what is sleep health or even circadian health. But if we look at sleep health, it's multiple domains. We have to be thinking about regularity. You'll see a lot of data that it's the regularity that seems, or lack of regularity, that seems to predict, let's say, Alzheimer's disease and as well as Parkinson's disease. We need to think about timing of sleep and wake as another domain of sleep health and satisfaction, so forth, but also, of course, duration. So I'm just going to show you quickly a few of these examples of that. So we think about the exposome, and one of those is light and light pollution during the night and insufficient exposure to light during the day. Shift work, our behaviors, our social and professional activities, our sleep-wake behaviors, our feeding, eating behaviors, all of these are going to affect our sleep health in these multiple domains that I just mentioned about. And of course, sleep disorders, which you will be hearing about as well. And all of these, in a very bidirectional manner, affect metabolism, affect really the function of most of the tissues of our body. And therefore, that type of dysfunction or misalignment and or lack of sleep has been associated with multiple disorders, neurologic, psychiatric, cardiovascular. You just go ahead and name it. It's just that this literature is just growing every day. So what's quickly some of this evidence would be, if you look at short sleep and cardiometabolic health, this is a meta-analysis, increases mortality, diabetes, cardiovascular disease risk, and obesity. Now you may say, what does that have to do with neurological health? A lot, because the cardiovascular metabolic system really is involved in many of the neurological disorders. Short sleep increases visceral fat. This is a study with 4 hours in bed versus 9 hours of time in bed. And what they found was it wasn't just the subcutaneous fat that was increased during the sleep, the short duration part of the study, but also, very importantly, visceral fat. What lacks in I think in our literature is, so what? I mean, can we actually make this better? So this is a very recent study by Ezra Tassali's group where they did a real-life intervention. They basically randomized people to 2 weeks of habitual 6.5 hours or less, or they increased time in bed to 8.5 hours. And they were able to increase sleep duration by 1.2 hours. What you can see here is that during the sleep extension period, those individuals consumed 270 calories less, which I think is quite, that's like what, one full donut. You can eat an extra donut if you sleep an hour more. And And even then, if you look at this, it is totally related to the amount of sleep. So the longer the sleep duration that was extended, the better, the lower amount of calorie intake. What about timing? That's the other domain, right? So this is a study from our group, but it shows this is in very healthy, young, pregnant women, newly parents women, that of course sleep duration increases the risk for gestational diabetes, as you would predict. But timing actually also does that. That's after controlling, adjusting for sleep duration. You can see that the odds ratio are quite high. I mean, we're looking really at almost 2 times the risk factor. That's using actigraphy as well. This is another study, large study of almost 13,000 people that we did some time ago using questionnaires. And what I just wanted to highlight is that late sleep timing, late midpoint of sleep timing on both weekends and also weekdays increases the risk for metabolic disorders. I'm going very quickly. How about if you're awake late at night, what are you doing? You're exposed to light, right? You're exposed to light. This is a sister study. This is by, this was given to me by Chandra Jackson. And they asked people, there was no objective look here, but they asked people whether they slept with their TV on, whether they had any light at night exposure while they were sleeping. And I was really shocked first that how many people slept with their lights on at night, especially television. And you can see that almost any light at night increased the relative risk for obesity in this group of women. I think this is quite, and I want to bring out the health disparities here, the ethnic things that Dana is going to be speaking about. Look who's mostly affected, right? It's really not the Hispanic Latinos, but also the non-Hispanic Black. We did a similar study, a larger scale with actigraphy now, as we talked about, and this is done by Minji Kim at Northwestern. And you can see that also light at night, measured by actigraphy, any light at night increase the risk for obesity and diabetes, as well as hypertension, the prevalence. So what about brain health? This is a typical actigraphy recording of a person with MCI in this case. You can see that during the arrows is the napping during the day and also very disrupted sleep during the night across the 7 days. Furthermore, Joe's group has shown that, that's a 2-minute, has shown that you can, or it's really over, gotta go. All right, sorry, so I'm gonna go, just showing that the sleep fragmentation is really associated, this type of sleep fragmentation is associated with increase in A beta as well as tau levels in the CSF of these actually healthy individuals. So we talked about slow-wave sleep, the decline in slow-wave sleep with aging. Why is that important? Because there's a relationship between the amount of slow-wave sleep with that of amyloid deposition in the prefrontal cortex as well as in these areas, as you can see by Mander's group. Finally, this type of sleep fragmentation, as you can see in actigraphy over here, is associated with increased risk for the development of Alzheimer's disease as well as that of just cognitive decline. And finally, this is really my last slide to show that, almost my last slide, to show that there's multiple factors here. We have sleep disorders, which I did not talk about, but we were hearing about sleep apnea, restless legs, hypersomnias, parasomnias, and circadian disorders. And in some of these disorders, there's gender differences within these, and they all lead to this common disruption of circadian, sleep-wake regulation, cardiometabolic, neuropsychiatric disorders, and multiple components are going to be involved in this. And finally, this is the opportunity here that at the end of the day this is what we are looking for. How can we now use these ideas to improving sleep and circadian rhythms? Can they be targets for disease modification really across the lifespan? So thank you.